Greetings. This is Shahid Muhammad, also known as the Math Doctor, welcoming all my students, illustrious students, to our week 1 of Word Problems Made Easy. I cannot stress how important it is for each of us to master word problems. I don't want you out there saying, I hate word problems. I love math. I just can't stand word problems. That's like saying I love to swim, but I hate water. Math problems or word problems are the essence of what math is all about. You learn math as a tool to solve real life problems. So whatever profession you all are going to go into, when you get out of college or when you get out of high school, whether it's a doctor, an engineer, a scientist, a carpenter, a plumber, whatever, you are going to experience real life scenarios and problems that are word problems. And you're going to need to know how to deal with them and how to solve them. So in these next 8 weeks, we will be looking at methods, strategies, and ways to solve word problems. And you will leave after these 8 weeks with a great appreciation of mathematics, word problems, and I'm hoping that you'll be more inspired and more motivated to solve word problems all the rest of your life. I'm sure that's going to happen. So let's go ahead and get started. We're going to lay a little foundation as we go into solving word problems. And we're going to pull up this PowerPoint real quick for you. So, solving word problems, the essence of mathematics. So let's look at some key things that we're going to need to know before we can even start solving word problems. There's some prerequisite skills that helps to edify your ability to solve word problems. And guess what? One of them is the ability to be able to read. Word problems, of course, requires reading skills. So if you are a good reader, you're going to be a good problem solver. The more you read and edify your reading skills and all the skills that go with reading, you're going to be able to transfer those skills to solving math word problems. So I'm hoping everybody out there that is in this session or watching this video, you are all good readers. Because if you plan to be a good solver of word problems, you're going to have to read. Reading is the key to all types of subjects. No matter what you want to study, you have to be a good sound reader. So let's put that phone down and let's pick up a book so that we can become better readers and thereby better problem solvers. So one of the first key things we need to solve word problems is we need to be able to have good reading skills. How do you get good reading skills? Be like Nike, just do it. So the more you read, you will edify, amplify your reading comprehension, your vocabulary, your understanding. All that's going to help you to transfer that and synergize those skills into solving word problems. Second thing that's good to have is as you're reading, be able to identify main ideas. There's going to be some word problems where they give you extraneous information. Now, what does that big word mean? Extraneous information is information that's not necessarily relevant to you solving the word problem. They just put it in there as fluff. Good to know, but you don't need it to solve the problem. So a good reader is able to identify the crucial information that's needed to solve the problem. So just like you need to identify main ideas to to read and to comprehend what you're reading, you need to be able to identify main ideas when you're solving word problems. The third thing that is very crucial to be able to do is after you read that word problem over and over and over, you want to ask yourself some questions. Number one, what is given in the problem? In every word problem, there's going to be some relevant information that they are going to provide for you that's crucial to solving the problem. You have to be like a detective and find out what are those relevant pieces of data, information that I need to solve this problem. Another thing you want to ask yourself as you're reading the word problem is, what do I know already? If there's a problem dealing with area, have they given me the length? Have they given me the width? It's a problem dealing with using a formula. What aspects of the formula are given to me in the problem? So what is given, you want to ask yourself, and what do I know already after reading the word problem? Now, very vital question that you have to ask is, what do I need to know? Because just as there's going to be things that they give you in the problem to solve it, there's going to be some unknowns that you have to come up with by reading, by deciphering, by analyzing the problem to see what is it I need to know. And guess what? The answer to the question of what you need to know is in the question. The word problem is going to have a question mark at the end. Hopefully, they're going to ask you this, find this, what is this? So there's going to be a question in the word problem, and that's where you answer the question, what do I need to know? It may say, what is the height? It may say, what is the sum? It may say, how much is known or how much is required? It may say, what is the total? So whatever the word problem is, it's going to have questions in the problem that answer or ask you to answer the question, what do I need to know? So those are three questions you definitely want to be able to go through and analyze to answer when you start reading your word problems. Another thing that's very crucial is vocabulary. The more vocabulary you are able to understand in the word problem, in its meaning, the better you'll be able to choose the correct method to solve the problem. Many word problems require you to use an arithmetic operation, add, subtract, multiply, divide, square root, divide, whatever. But you're going to know that by knowing the vocabulary, the terminology in the word problem is going to give you a cue to what to do. This sounds like multiplication. This means I have to divide. I'm breaking something into groups. This means I'm adding. I'm looking at the total. So there are some key words that I'm going to give you, and I have already uploaded on your course website where the course is found. Under week 1, you'll find these terms that I'm going to give you and go over in a few seconds. Then the last thing, or one of the another key thing to solving word problems is to have good reading comprehension skills. How do you gain those? You have to read again. So we're encouraging you to be good readers because you're going to be able to transfer that into being good problem solvers. Now, what we want to look at now are some of the basic steps to solve any problem. Now, not only am I giving you the steps to solve word problems, but you can solve this. You can use this for solving any problem in your life, financial, relationships, whatever. Problems with school, problems with people bothering you. I don't know, whatever the problem is. You can use these steps to solve any problem that you have in your life, but we're specifically using these to solve word problems, okay? Step number 1, you have to read the problem over and over and over until you understand the vital components of the problem. So reading it over and over truly helps to gain the crucial aspects of the problem, okay? We want to know, as I mentioned before, what do I know already? What do I need to know? And what is given to me? You're going to gain that information in the first step of problem solving. And that's reading the problem over and over and over until you gain an understanding of the problem. Step number 2 in solving any problem is after you come up with the understanding of the problem, then you got to do something. You have to devise a plan or strategy. So if I'm having problems with relationships, I have to first identify what the problem is. You're not speaking to me. We're not communicating. You're ugly, whatever the problem is. Once we understand the problem, then we'll be able to do what? Sit down and say, let's come up with a plan. So in solving word problems, after you read it, you have to come up with a sound plan in your mind. what am I going to do? What strategy would be good to solve this particular problem? Okay, so step number 2 is come up with a plan, a strategy. And guess what I'm going to do for you? The math doctor has medicine. I'm going to give you some strategies that you can use in your toolbox of solving word problems to solve different problems. I'm going to give you some tools for your toolbox. You should be happy about that. So after you devise a plan, what do you do now? Just sit there and look at the plan? No, you got to be like Nike. You got to just do it. So step number 3 is execute the plan. So if you go to the doctors and they say, hey, we understand what your problem is, your ailment, we have diagnosed it, you have such and such. This is our plan of action to rid you of this sickness or disease. And if the doctor just says, okay, see you later, and that's it, you're never going to be cured. Why? Because they didn't execute the plan. So number 3 in the steps to problem solving is to execute or work your plan. Now, many people think that's it. I got an answer, good. I move on to the next problem. No, no, no. Ice Cube had a song, check yourself before you wreck yourself. So after you execute the plan, you want to look at your answer, see, does it make common sense? If the problem said 2/3 of the amount of profit went to expenses and the money was $50,000 and you got an answer of $55,000, you know by checking yourself, that's wrong. Because 2/3 of 50,000 cannot be over 50,000. So this is what we mean by checking your answer, evaluating it. Did it make sense? Does it solve the ramifications in the problem? Does it solve the parameters of the problem? Okay. Now, I promised you tools for your toolbox. So I can't tell you to use a strategy and you don't know any strategies to use. So the next thing we want to look at in this video in week 1, what are some of the strategies you can use to solve word problems? We just don't want you to leave it on your own and read the problem and then you try to figure out what to do. We're going to provide you with some strategies. So here we go. One strategy you can use, depending upon the word problem, is to make a table or chart. Tables and charts are excellent ways to organize information. A lot of times when you're trying to see what's going on with the numbers, if they're all over the place and cluttered all over the paper or cluttered all over whatever and unorganized, you're not going to be able to find patterns. You're not going to be able to see connections or whatever, and you won't be able to solve the problem. So a table or a chart allows you to organize information so that you can use it later and begin to see relationships and connections. So that's one strategy. Strategy number 2, a very powerful strategy in mathematics, is to look for a pattern. You want to see, is there a pattern developing that I can predict 4 down the road, 10 down the road, 100 down the road, what's going on with this problem? And patterns are awesome ways to solve problems. Sometimes the problem might be a little more complex than you want it to be, might be a little more abstract. So one method or strategy is to solve a simpler problem. Look at a smaller problem that's similar to the one you're trying to solve. Solve that one, and then that will give you the method and means to solve the more complex or larger one. Another strategy, which is very powerful and helps a lot, is to draw a sketch. Many of you out there that's watching this video are visual learners. That means you learn very well by seeing things, by looking at things, by visualizing. So drawing a sketch allows you to see relationships or to get a picture of the words described in the word problem. Very powerful tool and strategy. Another strategy or tool is to use inductive reasoning. Now that sounds good, but what is it? Inductive reasoning is simply looking for a pattern and then making a prediction from that pattern. So if something happened on day 2, something else happened on day 4, something else happened on day 6, then you might predict the next thing is going to happen when? Absolutely correct. On day 8, because you used inductive reasoning. You saw a pattern. 2, 4, 6. The logical next term would be 8. A lot of times that's a very powerful way to solve word problems using inductive reasoning. Look for a pattern, and when you see it, you can make predictions. Okay? For all my future algebra students and pre-algebra students, the next tool is very useful in solving algebraic and pre-algebra word problems. And that's to write an equation, use an equation to solve the problem. Very powerful tool. Sorry about that. We had a little pop-up. But write an equation and solve it. And we're going to do some word problems at the end of this video. Well, not the end of this video, I'm sorry. At the end of the course, around week 8, week 7, we're going to go into solving word problems using equations. So I'm hoping that you get a little practice in solving equations in whatever class you're in right now in math class, or you can always go to YouTube and just get a little brush up on solving some basic equations. But I'm going to help you out as well when we get to that point. Another vital tool that you can use is to use a formula. Sometimes a word problem might deal with area, it might deal with volume, it might deal with temperature, it might deal with child dosage. Whatever the problem may be, it may be a formula connected to that word problem. And we need to be able to learn how to substitute numbers in to solve the problem using a formula. A very powerful tool is a work backwards. There are special word problems geared toward working backwards. We call them working backwards word problems. That's going to be in our 8-week course outline. You'll be able to see it if you go to the course website. I uploaded the course outline for you so you'll know the topics and the types of word problems we're going to cover for each week. And one of those weeks, we're going to deal with working backwards problems. Sometimes when all else fails, you just have to guess and check. And guess what? That is a strategy. We don't like to guess in mathematics, but sometimes that's what we have to do when the word problem is of that type of open-ended nature where we don't have a specific strategy. We can't identify a specific operation. We might just have to guess and check. And then last but not least is trial and error. So if you're trying to randomly choose some numbers that you think may work for the word problem, a good tool or strategy is trial and error. So these, my powerful students out there, these are just some of the many problem-solving strategies that you're going to get experience with in these 8 weeks, and you'll be able to use to solve word problems in the future. And that's going to make you a better, more powerful problem solver. So at this point, in week 1, after we looked at strategies, we looked at things that we need to be able to solve word problems. Now we want to get into our first type of word problems. And these are the most simplest types of word problems to solve. We call these our one-steppers. That means all we need to do to solve them is use one of our operations: add, subtract, multiply, or divide. So my 4th, 5th, 6th graders, this is right up your alley because you start off with your word problems a lot of times with just one-steppers, okay? And then we'll graduate as we go from week to week with more difficult, more perplexing, and more discombobulating word problems. But you out there being so powerful, it's not going to be a problem for you, I'm sure. We got math doctors out there watching the math doctor. Okay, here's our first word problem. Tyrone went to Supreme Hardware and bought a tool set for $189.12. He bought a lawnmower for $356.60 and a trimmer for $89.95. He has a coupon that gives him $50 off his purchase. The question is, when he goes to the cashier booth, how much will Tyrone pay in total? And I even made it a multiple choice question for you to get different looks at possible answers. But as we read this question, ask yourself, what type of problem would this be? Do I need to add? Do I need to subtract? Do I need to divide? What do I need to solve this problem? Now, what we're going to do before we go into it, we're going to go to those key words that I mentioned earlier. I uploaded the keyword list, and now I just want to bring it up as a document so you can see it and be able to know some of the key words that we can use to solve word problems. Here's the document right here. All right. So some of the key words, we have addition words. All right. Add, all together. So these are words, when you hear them and read them in the word problems, you'll know, hey, this means add, this means subtract, this means divide. Okay. So how many in all, combined, both, how much, in all these mean add. Increase by, plus, sum, together, and total. When you hear those words, they automatically mean add. What about subtract? We have the words like change. What is the change in temperature? What is the change in pressure? That always means subtract. Decrease by means subtract. Difference, fewer or fewer than means subtract. How many are left or how many are left over? How many did not have? How many more or how much more means subtract. And you're taking a higher amount from the lower. How much longer did something happen? How much shorter, heavier? How much fatter? How much bigger? How much taller? Less or less than means subtract. Loss, minus, need to, reduce, remain. All these mean subtract. Take away, of course. What about multiplication? We have by, dimension, double, each group, every. So whenever you hear something happens every day, each hour, each minute, that always means we're multiplying, okay? You're going to hear that a lot. If something is a factor of, that means multiply. Increase by, multiply by. Of is a very powerful word. It's small, only 2 letters, but when you put it with a fraction, it means multiply. So if the question said how much or the profit was 2/3 of something, that means 2/3 times. She lost 8/5 of, that means multiply. Okay, so of with the fraction amount always means you're multiplying that fraction by the quantity. Product means multiply, times, of course, triple, twice, quadruple, whatever. That means multiply. Some words that mean division, as much, cut up, each group has, it means you're dividing it into groups. Equal sharing, half, how many in each, okay? Parts, per, percent, quotient of, share something equally. So anytime you're breaking things into groups or you're dividing something in parts, equal parts, that is a division word or key term, okay? You can find, again, this document uploaded under week 1 on the course outline. So now let's go back to our word problem that we were working with Tyrone. So Tyrone is at the booth, the register. He's ready to check out. How much will Tyrone have to pay? Well, let's see. If he has items at the cash register, what do we know? Are we going to add, subtract, multiply, divide those prices? What you think? Absolutely. We're going to add, because that's what the cash register does. It adds up all the items purchased. And remember, he has a $50 off. When you hear that word off, that means take it off. Just like the song, take it off. So we have to take it off. That means we're going to subtract that amount off his total price. Let's look at how it's done. So the correct answer would have been C. The first thing we have to do is to get the sum of all the purchases Tyrone made. So we add up all the amounts, as you can see here. We're adding them all up. Remember, of course, when you're adding decimals, just as a review, you line up all the decimal places. You line up everybody that's in the same place value, okay? Once we add that, we get a total of $624.67 that Tyrone owes. However, he gives the cash register, or the cashier, the coupon. Hey, take my $50 off. So then we have to subtract $50 off of the $624.67, leaving Tyrone with a balance to pay of $574.67. So that was C for those that were doing it while you're watching this video. Okay? Let's go to our next problem. Jamal owns Fresh and Clean Car Wash. Y'all remember Outkast song, so fresh and so clean, clean, so fresh and so clean. Okay, I can't rap, but you get the point. So Jamal owns Fresh and Clean Car Wash. He had to spend 1/6 of, I was just talking about that word of, 1/6 of his profit. That means we're going to multiply 1/6 times his profit. On cleaning supplies, 1/5 on insurance, and 3/10 of his profit on payroll. So these are all the fractions of his profit that he's spending on different things. The question is, what is the total portion of his profit he had to pay out? So he paid out 1/6, that's a certain amount. He paid out another 1/5, and he paid out another 3/10. So we want to know, what is the total? Did we not just say total is a key word under what operation? Let me hear you. That is absolutely correct. Under addition. So we have to add all the fractions of the amounts coming out of the profit from Jamal's Fresh and Clean Car Wash. So this problem ends up being another addition problem. We have to add all the fractions up to get the total. Let's see how that's done, and let's see what the answer would be, A, B, C, or D. Some of you are so fast already, you chose your answer and got it. Let's check it out. So we're adding up here all the fractions, the 1/6, the 1/5, and the 3/10. You know, because you all are excellent students, that you cannot add fractions with unlike denominators. So what we have to do is change 6, 5, and 10 to what? The least common denominator. Man, you guys are awesome out there. So how do we find the least common denominator, 6, 5, and 10? Well, it's the smallest number all three of them go into. And guess what that number is? It is 30. In Espanol, that would be 30. For mi hablas español, estudiantes out there, all right? It's just a little Spanish, don't worry about it. So we're going to change them all to 30. To do that, 1/6 is the same as 5 out of 30. 1/5 is the same as 6 out of 30. And 3/10 is the same as 9 out of 30. So now that they're all the same denominator, we can add our numerators. Remember, you don't touch the denominator. We only add the numerators. So 5, 6, and 9 make 20. 20 out of 30. Remember, we never leave a fraction unsimplified. So break 20 out of 30 down, you get 2/3 when reduced. And that would mean that the correct answer was D. 2/3 is his total amount that he's paying out of his profit with those 3 fractional deductions. All right, y'all doing good out there? You getting all the answers? Future math doctors in the making. You all are awesome. Okay, let's go to our next problem. Uh-oh, somebody's doing push-ups. I'm hoping you all out there get your push-ups on, your sit-ups on, your running on, because exercise is key to good health. But let's get back to the problem. At the Worldwide Workout Gym, a trainer did a total of 315 push-ups in a week. Got that? 315 push-ups in a week. How many push-ups did the trainer do each day if he did the same number of push-ups every day? Now, there are some key words to think about in this problem. One is the word each day, and also he did the same number every day. So if he did a total of 315 push-ups in a week, we want to know how many he did in each day. All right. So we're going from a larger unit of time to a smaller, which means we have to divide. We want to find out how many he did per day if he did 315 in a week. So one of these is the correct answer. Let's see how we get this answer and what operation we're going to use. I kind of gave you a hint that we have to find the same number he did each day, and he did it every day. Each and every, or each in particular, means that we're dealing with division, because we have the scope of what he did in a week, but we want to break it up into groups of 7, because 7 is the number of days in a week. So the correct answer would end up being C. If the trainer is doing the same number of push-ups each day and does a total of 315 push-ups in a week, then that means he's doing a total of 315 push-ups in 7 days. So to determine how many he does each day or in one day, we have to divide, because we want to go from 7 days to how many he does every day. So we have to divide 315 by the number of days in a week, which is 7. And that means this trainer is doing 45 push-ups each day. Now I'm asking you all out there, my wise students, how can we check ourselves before we wreck ourselves? What can we do with the 45 to make sure that's the right answer? Let me hear you. Absolutely. You're awesome. All we have to do is do the inverse of divide to check. We multiply 7 times 45, and we should get what? 315. And if you all check it out there on your paper or your calculator, you'll see it is the correct answer. So this was a good example of a division word problem, because we had to go from how many done in 7 to how many done in 1. That means we're going from a group, or we're trying to get into groups of 1 for 7 days. Excellent, excellent. You guys are awesome. All right, next problem. Kevin Smith is an architect and has designed a new playground in the shape of an octagon. Now, you all know an octopus has 5 legs. Is that correct? No, you know that's wrong. An octopus has 9 legs. Is that correct? No. We know an octopus has 8. So that prefix, when you hear it, oct, means 8. So an octagon is a polygon with 8 sides. So Kevin built a playground, which is a polygon of 8 sides. And each side of the octagon measures 34.5 meters. So I want you to picture an octagon, and every side has a 34.5 on it. 34.5 meters on every side in an octagon. And how many sides in an octagon? 8 sides. How long would a fence have to be built to cover the entire playground? So we're putting a fence around this octagon. Picture that, okay? 8 sides, each side 34.5 meters. What do you think we're going to have to do to solve this problem? What operation does it sound like? Absolutely. I heard you out there. Multiplication. Because we have 34.5 on one or each, and there's 8 of them. So 8 around 34.5, 34.5, 34.5, 34.5. That would be the long way to do it, to add all those 34.5s. The quick way would be to multiply. Let's check it out. It ends up being the correct answer of A. If the playground is in the shape of an octagon, then it is a figure with 8 sides. The math doctor just said that. Each side measures 34.5 meters. Therefore, the total distance around the playground, also known as the perimeter, would be the 34.5 times the number of sides having 34.5, which is 8. So the perimeter, or the fence around this playground, would have to be at least 270 meters all the way around. This is a classic word problem Solve by multiplication, because you have how much for one and you're trying to find how much for more than one, and they're all the same. So instead of adding 34.58 times, multiplication is a quicker way to add. So we simply multiply 34.5 times 8. Are you all having a good time out there? Are you getting your math on? All right, let's move to the next problem with this powerful word problem video. Halima owns Happy Times Party Planners. Sounds like a wonderful company. She has been given a budget of $337.50 to purchase new tables for a graduation party. So how much money does she have? Absolutely. $337.50 is her budget. And she's buying tables for a graduation party. Each table, there's that word each, costs $22.50. How many tables can she purchase? So think about you in the store with $337.50 in your wallet, in your pocket, in your cash app, whatever, however you roll with your money, your dinero, your ducats. You have that amount of money. You want to buy as many tables as you can get with $337.50, and each table costs $22.50. Now, there's a long way you could do this. You could take your money amount and buy one table. What does that mean? You would subtract $22.50 minus your amount, $337.50. Then you would have some money left. Hey, I can buy another table. You would subtract $22.50 from that remaining amount. Hey, I still got some left. I can buy another table. You would subtract that. That would take a long time. But thank God for division, because division, family, is a quicker way to what? Subtract. So instead of subtracting 2250, stop right there. All you got to do is divide. You want to find out how many 2250s go into $337.50, because every one that does is another table that Halima can purchase. Let's look at it. The correct answer ends up being D. If her budget is $337.50 and each table costs $22.50, then we have to determine how many 2250s, as I said earlier, are in $337.50. In other words, the quick way is to divide. So if we divide that, whether you're going to do it long division or with your calculator, you would get an answer of 15. So since there are 15 2250s in $337.50, that allows Halima to buy or purchase 15 tables in all. Does that make sense to you? I know it does, because you're an awesome, powerful math student. Let's go to our next problem. Oh, some of you get a little hungry out there. I see you looking at the screen. Raymond owns Chocolate Delights Candy Shop. Notice I have a lot of people owning their own businesses, because I'm trying to encourage you to not settle for just getting a job, but to use your powerful math skills to make a job for yourself, make a company for yourself, run your own business. I want you to be in charge, running things, the boss. Got it? Very good. Can't do it without math. Raymond owns Chocolate Delights Candy Shop. The delivery service delivered 20 boxes of candles. 20 boxes of candies for 5 days in a row. Did y'all get that? I had to read it over. So the delivery service delivered 20 boxes of candies 5 days in a row. You got that part? If each box of chocolates contains 12 chocolates, all right? So every box has 12 chocolates in the box. They delivered 20 boxes for 5 days in a row, okay? How many total chocolates did the delivery service deliver in all? There's those words, in all, that tells you we want a total. We want a grand total in all. What do you think we need to do to solve this problem? Some of you said add, and some of you said multiply. Remember, multiplication is a quicker way to add. So let's stop and think. If they delivered 20 boxes for 5 days, what does that tell us? That tells us in 5 days how many boxes were delivered. 20 times 5. If you do 20 for every day, 5 days, that's 5 times 20. That means in 5 days, they would have delivered what? Absolutely, 100 boxes. And now you know the total number of boxes. That will let you know the total number of chocolates, because there's what? 12 chocolates in each box. Okay, so let's look at the solution. The correct answer would be A. If the delivery service delivers 20 boxes of chocolates for 5 days, then that would be 20 times 5 chocolate boxes, or 100 boxes of chocolates. We went over that. Now, if every box contains 12 chocolates, then there's 100 chocolates in all, or 12 times 100 chocolates in all, because there's 100 boxes, 12 chocolates in each box. And all you would do, the quick way, would be to multiply 12 times 100. So the correct answer was 1,200 chocolates in all. Okay, next problem. 2 racers are racing around a circular track. Speedy Steve can circle the track in 6 hours. Fast Fred can circle the track in 8 hours. Now, this actually, my students, is a good example of where a diagram or sketch would help. Because I want you to imagine that Speedy Steve can circle the track in 6 hours. Fast Freddy can circle the track in 8 hours. You got it? If they all start at the same starting line and at the same time and move out, what will be the next time in hours that they are side by side again? So remember, one is going around every 6 hours. Every 6 hours, they complete a circle. Every 6 hours, while the other one is completing a circle every 8, every 8, every 8. So every 6 and every 8 should remind you something powerful for mathematics called multiples. Because if you go to your multiplication chart, every 6 on the multiplication chart is another multiple of 6. Every 8 on the multiplication chart is another multiple of 8. Okay, so we're trying to find something that you all might remember from middle school. We're trying to find what is called the least common what? Multiple. Absolutely. I knew you learned that in school. So let's see how to do this. The correct answer ends up being C. Why? This problem involves determining the least common multiple. This means finding the smallest number that both numbers go into. Now, one can complete the track in 6 hours, while the other takes 8 hours. So we have to find the least common multiple of 6 and 8, meaning what? The first number that is in both multiplication rows for 6 and 8, or the first common multiple that we find in 6th row and in the 8th row. So what I did is laid out for you that in the 6th row, you have 6, 12, 18, 24. So these are the hours when the first racer would keep coming back to the starting point, all right? After 6, after 12, after 18, after 24, after 30, after 60, after 40, and so on. The next racer would come back to the starting point at 8 hours, 16 hours, 24 hours, 32 hours, and so on. If you look at both rows, the first time that both of them have the same number is at 40. Oh, no, I'm sorry, at 24. They do have 40 in common as well. But the first time that they both have the same number in their multiplication row of multiples is 24. So at the 24th hour, both of them would return to the starting point, and they would be side by side again, ready to start another revolution and come back around again. So you got it? So this was a problem dealing with least common multiple, finding the first number that both of them would be or have completed a full revolution at. And that is after 24 hours. 24 is the least common multiple of 8 and 6. So this is a good real world problem that shows you how least common multiple is used. Because a lot of us learn least common multiples, but we don't know, where do I use it? When am I going to see this before? What do I care about this thing called least common multiple? Well, here is a beautiful example from the math doctor of applying least common multiple. So you make sure you master that bad boy in class and pay attention to LCM and also GCF. Okay, let's go to our next problem. This will be our last one stepper on this video. Then I have uploaded for you a worksheet with some problems that you can do on your own. And I want you to do them, post them, and then the math doctor will take his math stethoscope and check you out and see whether you solve the problems correctly. All right? So this is the last one, and then you'll be on your own to solve some problems that I uploaded for you. Bilal is a fire marshal. He requires every fireman to clean out 8 pairs of boots per day. That's a little rough. He's putting them to work. Besides having to put out fires, they got to clean boots. What a rough fire marshal. So they have to clean 8 pairs of boots per day. Got it? He rewards a fireman who washes a total of 112 boots with a free dinner. Isn't that a nice fireman or fire marshal? How many weeks would it take a fireman to get rewarded? Meaning, after how many days of washing boots would he reach a total of 112? So he's washing 8 boots per day. We know there's 7 days in a week. You got to find out how many weeks would it take the fireman to get rewarded, meaning to reach a total of 112 boots. Now, what we could do is add, right? We could say one day 8, second day another 8, that's 16. Third day another 8, that's 24. Fourth day another 8, and so on. But that would be a long, tedious process to keep adding until we get to 112. What could we do quicker, expeditiously, and more efficiently? Check it out. We know that in 1 week, it's 7 days. So let's say he worked consistently for 7 days. How many boots would he have cleaned? It would be 8, how many does per day, times 7, which means in 1 week, the firemen wash 56 boots. Interesting. So 1 week, 56 boots. How many boots in 2 weeks? Wouldn't it just be 2 times 56? And bam, guess what 2 times 56 just happens to be? 112 boots. You've answered the problem in a short amount of time. Therefore, it would take the fireman 2 weeks before he can enjoy that beautiful dinner for winning the prize of washing 112 boots. So family, my beautiful students, mi estudiantes in Espanol or Spanish, we hope that you gain some powerful tools, strategies to start solving word problems. We also hope that you are equipped now with the methodology, the strategy, and the means to solve what we call one-steppers. That means word problems where all you have to do is determine the correct and appropriate operation out of our 4 primary operations: add, subtract, multiply, and divide. Next week, our second week, we are diving right in to not one-steppers. No, we're going to turn up and we're going to go to multi-step word problems. That means you're going to have to turn up into doing more than one operation. But I know you're ready. I know you're powerful. And I know you are future math doctors yourself. So stay tuned. Same time, same station. We will turn up our math exegesis and deal with word problems where we are required to use multiple steps. So your homework is loaded on and under week 1 in the course template or on your course website. So check that out. I'll be looking forward to seeing your correct and right answers. I look forward to seeing you using the proper tools and strategies to solve these problems. May God bless each and every one of you. Have a beautiful week and get your math on. Read, 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 so you can turn up your math skills. Take care. Out. Peace from the Math Doctor.